Once we've covered the EV EMS part, the skeleton of a project, which is to maybe deploy a hub in a shared infrastructure building where we have an EV panel that will feed dozens of chargers, or if you have connection to the meter, so typically in the smaller buildings, you might have the meters available nearby the parking lot, where it makes sense to take the power directly from there. So depending on which of the two situations you have, we have two types of control system at RVE. I'm going to start with shared infrastructure application and introduce you to the SMP Plus. The SMP is a smart metering panel that aims really to help with rental properties, high rises, where we have a dedicated EV infrastructure that needs some power management, that needs some billing, and that's exactly where the SMP will enable to power more cars with less. The goal of the smart metering panel is to enable to connect a maximum of EV chargers to the smallest infrastructure possible, while maintaining equity of charging, so that everybody gets a full charge every morning, but without breaking the bank. So protecting the infrastructure, reducing peak demand charges that can get really expensive if there's too many electric cars. Also important to note, the SMP is compatible with all brands of distribution panels and all charging stations. So it's really a product that is super flexible. It's agnostic to everything on the market, which makes it much easier to deploy. In terms of its design, it is made for obviously some large-scale deployment. So we have buildings where we have SMPs that will eventually power, hundreds of cars. And to make sure we protect the infrastructure, well, we've included some features that enables us to do multi-level energy management system. That's really the only way to comply with Rule 8-106-11. It's to have CTs that monitors both the main service and the sub feeders, but that also have relays with fail-safe features in BEAD that will make sure that if there's ever a miscommunication along the way, that we can stop the charging and assess the trouble if ever there's one. We request to have Ethernet connection for us to provide real-time monitoring or consumption data. But if the internet goes down, it doesn't matter in terms of all the critical and decisions, everything will run smoothly. How does the algorithm work? How does it prioritize the different users? So since we're monitoring each individual branches, we know exactly how much car A received in terms of energy in the last 12 hours, and car B, how much energy they got. So we're able to balance not only the power going to each car, but also to balance the loads. Because EV chargers at 208 volt are single-phase devices, but we're almost always on three-phase systems. So the algorithm will also take that into account to make sure that we balance the phases, which will help transformers and hopefully give it more life longevity. Here on the screen, we have a single line diagram of a typical project where we would have a limitation at the main service level. So we would want to monitor the main service with a hub, for example, that can speak backnet through a RS-485 connection to the different SMPs that would be fed by a transformer that is just for the EV panel, for example. So that's a pretty typical installation that we see quite often in Canada, where we have 600 volt design. The same could go for the United States. obviously. But in this case, the beauty of monitoring both the main service and the sub panel for EVs enables us to subtract from the load calculation all the EV loads and basically maximize when we're charging cars depending on real-time consumption of the building. So really interesting features that are developed with the hub and SMP configuration, and hopefully that helps you win more jobs in the future. As far as factory setting goes, what we require when we get an order is that we get the max amperage per products that you are allowing us to control, meaning that when we certify our products before we ship it to the customers, we make sure that we hard code all the critical decisions directly at the factory. The reason being that we don't want the end users to be able to play with the software or through an apps and change everything that is kind of mission critical, and also enables you with quarterly free report for all the billing of the chargers. So that completes my presentation around the SMP